In 1964, Ford built an engine so advanced that NASCAR banned it before it ever turned a lap in competition, an overhead cam V8 that made 616 horsepower in street trim and over 650 on the track. It was so threatening that Bill France himself rewrote the rulebook rather than let it race. This is the story of the 427 single overhead cammer, the engine that was too fast for its own good, and how the greatest NASCAR motor ever built never got to prove it on Sunday. Picture the dynamometer cell at Ford's Romeo engine plant in early 1964. The numbers coming off that dyno tell a story Ford's engineers already know will change everything. These aren't numbers from a race-only prototype or a hand-built special. This is a production engine, or at least it's supposed to be. Ford has committed to building enough of them to meet NASCAR's homologation requirements. They've designed tooling, allocated factory space, and prepared to put this machine into crate form for any racer with a checkbook and a death wish. The Cammer represents everything Ford learned from racing in Europe and applied to American muscle. It borrows overhead cam technology from the GT40 program, valvetrain geometry from Formula One, and breathing dynamics that leave pushrod engines choking in its wake. Each head carries a single camshaft driven by a 6-foot timing chain running up the front of the block. Valves sit in hemispherical combustion chambers, actuated directly by the cam with minimal friction and maximum control. At high RPM, when pushrod valve trains start floating and losing control, the cammer just keeps pulling. Ford's racing division knows exactly what they've created. This engine will dominate NASCAR if given the chance. It will embarrass Chrysler's HEMI. It will make GM's Mark IV look outdated before it even reaches production. The Cammer isn't just faster. It's a different category of technology, and everyone in that test cell understands the implications. But there's a tension in the room that has nothing to do with horsepower. NASCAR's rulebook was written for pushrod engines, for technology that's been around since the 1940s. The sanctioning body has never seen anything like this, and Bill France doesn't take kindly to manufacturers who threaten the competitive balance he spent 15 years building. Ford is about to find out that being too good can be worse than not being good enough. The year was 1963, and American motorsports was locked in the most expensive arms race it had ever seen. Ford, Chrysler, and General Motors were pouring millions into racing programs, each one convinced that Sunday wins would translate to Monday sales. NASCAR had become the proving ground for American performance, and the manufacturers were building engines that pushed the boundaries of what production-based meant. The money flowing into racing was staggering. Ford's Total Performance Program, launched in 1962, had a budget that exceeded $10 million annually, equivalent to over $100 million in today's money. This wasn't just about winning races, it was about corporate pride, about proving to shareholders and customers that your engineering was superior. Lee Iacocca, then running Ford's car and truck group, understood that racing success created a halo effect over the entire product line. A win at Daytona didn't just sell Galaxies to speed enthusiasts, it made every Ford seem faster, more desirable, more American. Ford had reason to be aggressive. They'd watched Pontiac dominate the early 60s with powerful engines and factory support, only to see GM implement a corporate racing ban in January 1963. That left Chrysler and Ford to fight it out, and Chrysler came to the track with a weapon Ford hadn't anticipated, the 426 HEMI. When Richard Petty swept Daytona in February 1964 with the new HEMI under the hood, Ford's racing brain trust realized they had a serious problem. The HEMI wasn't just powerful, it was efficient, breathing through massive valves arranged in hemispherical combustion chambers that let the engine make torque everywhere and horsepower at the top end. Chrysler's engineers had achieved something remarkable. A big block engine that made power like a race motor but remained tractable enough for street use. The combustion chamber shape allowed for larger valves without sacrificing compression ratio, and the cross-flow head design meant intake and exhaust gases didn't fight each other for space. Ford's 427 FE engine was strong, but it was a pushrod motor fighting an uphill battle against better breathing and more advanced combustion chamber design. If Ford wanted to win, they needed to leap past Chrysler's technology, not just match it. Behind the scenes, Ford had been working on overhead cam technology for years. Their European divisions had been racing overhead cam engines since the 1950s, and the GT40 Endurance program was teaching Ford's engineers how to make exotic valve train designs survive under racing conditions. The British and German engineers Ford employed for their European operations brought decades of experience with overhead cam configurations, knowledge that had been refined on Formula One grids and endurance tracks from Le Mans to the Nürburgring. The question wasn't whether Ford could build an overhead cam V8. The question was whether they could make it legal for NASCAR. NASCAR's rules in 1964 required any engine used in competition to be available to the public in production vehicles. The sanctioning body set minimum production numbers, typically around 500 units, to ensure that race engines bore some resemblance to what customers could buy at dealerships. This homologation rule was NASCAR's way of keeping racing relevant to street cars and preventing manufacturers from building pure race engines with no production intent. The rule made sense in theory. It kept costs somewhat controlled and maintained the fiction that stock car racing actually involved stock cars. Ford's plan was audacious. They would design the overhead cam motor as an optional engine for the Galaxy and Fairlane, build the required number of units, and present NASCAR with a fait accompli. The engine would be expensive. Estimates suggested a $2,000 option price, or about $20,000 in today's money. But it would technically be a production engine. Ford Racing's executives believed that if they met the letter of the law, NASCAR would have to approve it. They'd done the math. They'd studied the precedents. They believed rules mattered more than politics. What they didn't account for was Bill France's growing concern about runaway spending and technological escalation. France had built NASCAR from a regional racing series into a national phenomenon, and he'd done it by carefully managing the balance between entertainment and accessibility. He'd watched the horsepower war spiral out of control, with factories spending fortunes on engines that bore less and less resemblance to what ordinary customers drove. He'd seen Chrysler introduce the HEMI and watched Ford respond with anger and threats to quit racing altogether. France knew that if he approved the Cammer, GM might return to racing with their own exotic engine, and the whole structure of stock car racing could collapse under the weight of factory spending. His nightmare scenario was simple. Manufacturers would spend themselves into withdrawal, leaving NASCAR with empty grids and no factory support. The stage was set for a confrontation. Ford had the engine, NASCAR had the rulebook, and neither side was interested in backing down. Pull the valve covers off a 427 Cammer, and you're looking at a different philosophy of engine design. Where a pushrod motor uses a camshaft buried in the block, pushing valves open through a complex chain of lifters, pushrods, and rocker arms, the Cammer puts the camshaft right above the valves. Each cam lobe sits directly over a valve stem. No intermediaries, no energy lost to reciprocating mass. Just a cam pressing down on a bucket-style lifter that opens the valve with mechanical precision. This matters more than it sounds. In a pushrod engine, the valve train has mass and flex. At high RPM, the pushrod can bend, the rocker can deflect, and the whole system starts losing control of valve motion. Engineers call it valve float, and it's the invisible ceiling that keeps pushrod engines from spinning past 6,500 RPM reliably. The physics are unforgiving. As engine speed increases, the acceleration forces on the valve train components increase exponentially. A pushrod that weighs just a few ounces becomes a liability at 7,000 RPM, flexing and oscillating in ways that prevent precise valve control. The Cammer doesn't have that problem. With minimal mass between the cam and the valve, the engine can spin to 7,500 RPM and maintain perfect valve control. Ford's engineers borrowed the basic architecture from their European Formula One program, but scaled it up to American V8 proportions. The result was a 427 cubic inch engine, the same displacement as Ford's pushrod FE motor, but with a completely different personality. Bore and stroke measured 4.23 inches by 3.78 inches, a combination that favored high RPM operation over low-end grunt. This was an intentional choice. NASCAR racing in the mid-60s meant sustained high-speed running, with engines spending hours at 6,000 RPM or higher. The Cammer's bore-to-stroke ratio was optimized for exactly that scenario, maximum power where it mattered most. Compression ratio sat at 12.0 to 1 in race trim, high enough to extract maximum energy from premium fuel without crossing into detonation territory. The combustion chambers used a hemispherical design similar in concept to Chrysler's HEMI, but with valves actuated from above rather than through push rods. This gave Ford engineers incredible control over valve timing and lift. They could run aggressive cam profiles that would destroy a pushrod motor's valve train, opening valves faster and holding them open longer to maximize airflow. The cam profiles Ford developed for the Cammer were radical by 1960s standards. Valve lift exceeded 0.6 of an inch, and duration numbers pushed well past 300 degrees. In a pushrod engine, trying to run those specs would result in broken rocker arms and damaged valve springs within minutes. The Cammer handled it without complaint. If you're enjoying this deep dive into automotive engineering history, hit that subscribe button. We've got more stories about the engines that changed racing forever. According to dyno testing, the Cammer flowed 30% more air than the FE at peak RPM, and that translated directly to horsepower. Airflow is everything in an internal combustion engine. It's the fundamental constraint on power production. You can optimize ignition timing, perfect fuel delivery, and machine combustion chambers to tight tolerances. But if you can't get enough air and fuel into the cylinder, you won't make power. The Cammer's overhead cam design, combined with its hemispherical combustion chambers and large valves, created an engine that breathed like nothing else in American motorsports. The timing chain system was a masterpiece of mechanical engineering and a potential nightmare for reliability. Ford used a single roller chain that ran from the crankshaft up to the cam on the passenger side across the front of the engine to drive the opposite cam and back down to the crank. Total chain length exceeded 6 feet, making it the longest timing chain ever used in a production automotive engine. Engineers worried about stretch and harmonics, about whether a chain that long could maintain precise cam timing under racing conditions. During development, Ford tested multiple chain configurations, experimenting with different link designs and tensioner systems. The final design used a heavy-duty roller chain with spring-loaded tensioners at strategic points to prevent slack and control vibration. Testing showed the chain could survive thousands of racing miles if properly tensioned, though the complexity of the system made proper installation and maintenance critical. Lubrication was critical. The camshafts needed constant oil flow to survive high-speed operation, so Ford routed pressurized oil through galleries machined into the cylinder heads. Oil pressure at speed exceeded 80 psi, force-feeding bearings and cam lobes with a constant supply of lubricant. The oil system was designed with redundancy in mind. Multiple feed passages ensured that even if one gallery became restricted, oil would continue reaching critical components. The system worked, but it was complex and expensive to manufacture, another sign that this engine was pushing the boundaries of what production meant. The block itself was cast iron, a concession to durability and cost. Ford's engineers had considered aluminum, but the stress loads in a 427 cubic inch race engine made cast iron the safer choice. The heads, however, used aluminum castings with steel valve seats pressed in place. This combination gave Ford the strength they needed in the block while keeping the top end light enough to maintain reasonable vehicle weight distribution. In street trim with a single 4-barrel carburetor, the Cammer made 616 horsepower at 7,000 RPM. That number deserves context. In 1964, the average family sedan made about 200 horsepower. High-performance engines from Pontiac and Oldsmobile topped out around 350 horsepower. Even Chevrolet's legendary small block, in its hottest street configuration, barely cracked 400 horsepower. Ford had built an engine that made 50% more power than anything else you could order from a dealership. But street trim wasn't the full story. In NASCAR trim with dual 4 barrels and race exhaust, dyno testing showed output exceeding 650 horsepower at 7,200 RPM. For context, Chrysler's 426 HEMI made about 425 horsepower in street form and roughly 550 to 575 in full race spec. The Cammer wasn't just better, it was generationally ahead, the kind of performance leap that only happens when someone fundamentally rethinks how engines work. But every revolution has its breaking point, and this one was about to face the most powerful resistance. Mechanism in American Motorsports, Bill France's rulebook. The confrontation began quietly, in conference rooms and phone calls between Dearborn and Daytona Beach. Ford submitted homologation paperwork for the 427 single overhead cam in late 1964, confident that they'd met NASCAR's production requirements. They had engine assembly tooling installed at Romeo. They had part suppliers lined up. They'd even photographed prototype Galaxies with Cammer engines installed, ready to prove the motor could fit in a stock chassis. The documentation was thorough, anticipating every question NASCAR might raise about production intent and availability. NASCAR's response was not what Ford expected. Bill France didn't reject the engine outright. Instead, he delayed approval, requesting more information, more documentation, more proof that this was truly a production engine. Weeks turned into months. Ford's racing division grew increasingly frustrated, watching the 1965 season approach with no clarity on whether their new weapon would be legal. The delay itself was a tactic. Every week, without approval, was another week Ford couldn't prepare race cars. Another week, their competitors gained advantage through certainty. Behind the scenes, France was facing pressure from multiple directions. Chrysler executives were furious that Ford had leapfrogged their HEMI with exotic technology. They argued that overhead cam engines violated the spirit of stock car racing, that they represented a level of engineering sophistication that had no place in vehicles marketed to the public. Chrysler's position was self-serving but not entirely wrong. The Cammer was exotic in a way that previous NASCAR engines weren't. It represented a philosophical break from the pushrod architecture that had defined American V8s for decades. Chrysler threatened to withdraw from NASCAR if the Cammer was approved, a move that would leave France with only one factory team and a weakened championship. The Chrysler threat was credible. They'd invested millions in HEMI development and had finally achieved competitive parity with Ford. Approving the Cammer would make that investment worthless overnight and force Chrysler to either respond with their own overhead cam program or accept permanent second-place status. Neither option appealed to Chrysler's board, and they made it clear to France that they viewed NASCAR's decision on the Cammer as a test of whether the sanctioning body valued long-term manufacturer relationships over short-term performance gains. France had another concern that he discussed privately with sanctioning body officials: cost. The Cammer was expensive to build and would be expensive to buy. If Ford could race it, other manufacturers would need to respond with equally exotic engines or give up on competitive parity. The horsepower war was already straining factory budgets. Approving the Cammer might accelerate spending to the point where manufacturers simply walked away from the sport. France had seen this pattern before in other racing series, unlimited technical development leading to skyrocketing costs followed by manufacturer withdrawal and series collapse. He was determined not to let NASCAR follow that path. In January 1965, France made his decision. NASCAR announced new rules for the upcoming season. Overhead cam engines would not be permitted in Grand National competition unless they were installed in production vehicles sold to the public in significant numbers. The specific language was carefully chosen. NASCAR didn't say Ford couldn't build the Cammer. They said Ford couldn't race it unless they sold it in actual cars, not just as crate engines to racers. The distinction was subtle but devastating. Ford could meet the letter of the old rule by selling crate engines, but the new rule required complete vehicles. Ford protested immediately. They argued they'd met the homologation requirements, that NASCAR was moving the goalposts after Ford had invested millions in development. Internal Ford memos from the period show genuine anger at what executives viewed as favoritism toward Chrysler, and a betrayal of the rules-based system NASCAR claimed to uphold. One memo, written by a senior Ford racing executive, called the decision a transparent attempt to protect Chrysler's investment at the expense of superior engineering. Ford Racing's leadership seriously discussed pulling out of NASCAR entirely, viewing the Cammer ban as evidence that NASCAR couldn't be trusted to apply rules fairly. The political maneuvering got worse. Chrysler, sensing an opportunity, made a strategic concession. They agreed to install the 426 HEMI in actual production vehicles, Dodge Chargers and Plymouth Satellites, making it a true street engine available to customers. This gave France cover to approve the HEMI while continuing to block the Cammer. Chrysler had outmaneuvered Ford not with better engineering, but with better politics. They'd read the situation correctly, understanding that France needed a face-saving way to maintain manufacturer participation without approving exotic technology. By mid-1965, the situation had reached a stalemate. NASCAR wouldn't budge on the overhead cam ban. Ford refused to invest in putting Cammer engines into street cars when the market for a $2,000 performance option was virtually non-existent. The economics didn't work. Even the most optimistic market analysis suggested Ford might sell a few hundred Cammer-equipped cars at that price point, nowhere near enough to justify the tooling and assembly line modifications required. The fastest engine Ford had ever built sat on the sidelines, legal for drag racing and boat racing, and virtually every other form of motorsport except the one Ford had designed it to dominate. Internal company documents reveal the heartbreak among Ford's engineering staff. They'd created a masterpiece, proven it on the dyno, and watched politics kill it before it ever reached the track. One engineer noted in a project debrief, "We built the best engine in NASCAR history. NASCAR made sure it would never matter." The bitterness in that statement reflected a broader frustration within Ford's engineering community, the sense that innovation was being punished, that playing by the rules meant nothing if the sanctioning body could simply change them when convenient. The immediate reaction from the racing community was disbelief and disappointment. Racers who'd seen the Cammer on dynos and test stands knew exactly what Ford had created. They understood that NASCAR had just banned the most powerful production-based engine ever designed for oval track competition. The decision wasn't about safety or fairness. It was about control, about Bill France maintaining the authority to shape NASCAR's technological direction regardless of what the rulebook technically allowed. Magazine coverage reflected the controversy. Car Life called it the fastest street engine America has ever seen and may never see again. Hot Rod ran dyno comparisons showing the Cammer making 75 more horsepower than the HEMI in equivalent trim. The numbers were undeniable, printed in black and white for readers to see. Drag racing publications were more direct, with one writer noting that NASCAR had chosen political stability over technological progress. The racing press, generally supportive of NASCAR, found it difficult to defend a decision that explicitly banned superior technology. Ford's response was to flood the Cammer into every racing series that would accept it. NHRA approved the engine for drag racing, and it immediately became the dominant power plant in top fuel and funny car classes. Cammer-powered dragsters routinely clicked off mid-7-second quarter miles, performance that seemed impossible just years earlier. The engine's combination of high RPM capability and reliable power delivery made it ideal for drag racing, where engines needed to survive just a few seconds of full throttle operation, but had to do so repeatedly through elimination rounds. The engine found success in offshore powerboat racing, where two Cammers could push a 30-foot boat past 100 miles per hour. In marine applications, the Cammer's ability to maintain high RPM for extended periods proved valuable. Offshore races could last hours, and the engine's robust lubrication system and precise valve control translated to reliability in the harsh saltwater environment. Anywhere NASCAR's rules didn't apply, the Cammer won. Sales numbers tell the story of an engine without a home. Ford built approximately 657 Cammer engines between 1965 and 1967, far short of initial production projections. Without NASCAR legality, there was no reason for stock car teams to buy them. Drag racers snatched up most of the production run, paying around $1,900 per engine. Expensive, but worth it for guaranteed wins. A handful went to boat racers. A few dozen ended up in the hands of wealthy enthusiasts who wanted the most exotic American V8 money could buy. Men who hung the engines in custom hot rods or simply displayed them as mechanical art. Ford continued to race the pushrod 427FE in NASCAR through 1968, winning races but never achieving the dominance they'd anticipated with the Cammer. The company's relationship with Bill France remained strained. Ford briefly withdrew from NASCAR in 1966 over tire and aerodynamic disputes, a move that many insiders believed was payback for the Cammer ban. When Ford returned in 1967, they did so with less enthusiasm and smaller budgets, their confidence in NASCAR's rulemaking process permanently damaged. Inside Ford, the Cammer's failure had consequences beyond racing. It convinced management that exotic engineering was a poor investment if sanctioning bodies could simply legislate it out of existence. Future performance programs would focus on engines that fit within established frameworks rather than pushing technological boundaries. The Cammer became an object lesson in the limits of innovation when politics control the playing field. Engineers learned that technical superiority mattered less than political relationships, a lesson that would shape Ford's motorsports approach for decades. Yet, even in defeat, the engine earned respect. Racers who ran Cammers in drag competition spoke about them with reverence. The engines were reliable, powerful, and smooth. They didn't break. They didn't overheat. They simply made power lap after lap, pass after pass. One drag racer noted in a period interview, "You could tune a HEMI for months and maybe find another 20 horsepower. With the Cammer, you bolted it in, fired it up, and you were already faster than everyone else." That reputation for effortless superiority defined the Cammer's legacy outside NASCAR, an engine that made winning too easy. But history has a habit of rediscovering what it once discarded. Decades after NASCAR banned it, the 427 single overhead cam Cammer has become one of the most collectible American engines ever built. Survivors command extraordinary prices. A complete original Cammer engine in running condition sells for $30,000 to $50,000 today, and pristine low-mile examples have topped $75,000 at specialty auctions. That's more than many complete cars from the era, a testament to the engine's rarity and mystique. The market for Cammers remains strong because supply is strictly limited. Ford only built those 657 engines, and attrition through racing, neglect, and parts harvesting has reduced the number of complete survivors significantly. The Cammer influenced American performance in ways that weren't obvious at the time. It proved that overhead cam technology could work in a large displacement V8, laying conceptual groundwork for engines that would emerge decades later. Ford's modular V8 family, introduced in the 1990s, used dual overhead cams and many of the breathing principles the Cammer pioneered. The current Coyote 5.0 liter in the Mustang GT owes a direct lineage to lessons learned in Romeo back in 1964. Engineers who worked on the Cammer program later applied that knowledge to subsequent Ford performance projects, creating a through line from the banned race engine to modern street performance. Drag racing remembers the Cammer as one of the sport's dominant engines of the 1960s and early 1970s. Top Fuel teams ran them until purpose-built HEMI race engines pushed displacement past 500 cubic inches, and even then, Cammers remained competitive. The engine's reputation for reliability under extreme conditions made it a favorite among professional teams who couldn't afford failures during elimination rounds. Several Cammer-powered cars set NHRA national records, and the engine remained legal in various classes until the sanctioning body mandated specific engine architectures in the 1980s. Some of those records stood for years, testament to how far ahead of its time the Cammer really was. The collector and restoration community treats original Cammers with a level of care usually reserved for exotic European engines. Owners document provenance obsessively, tracking serial numbers back to Ford's production records to verify authenticity. Reproduction parts are nearly non-existent because the engines were never mass-produced, so rebuilds require sourcing original components from other engines or fabricating parts from scratch. That 6-foot timing chain? You can't buy a new one. You need an original, or you need someone to custom manufacture a replacement to exact specifications. Rebuilding a Cammer correctly requires specialized knowledge, and only a handful of engine builders in North America are trusted with the work. These builders charge premium prices, but Cammer owners pay willingly, understanding that proper work is the difference between a museum piece and a running engine. Modern engine builders have occasionally recreated the Cammer concept using contemporary technology. Aftermarket companies have offered overhead cam conversion kits for Ford FE blocks, and custom engine shops have built billet versions of the Cammer architecture with modern materials and CNC precision. These modern interpretations can make over 800 horsepower naturally aspirated, proving that the basic design still holds merit 60 years later. The fact that engineers continue returning to the Cammer's architecture suggests it got something fundamentally right, that the path Ford chose in 1964 was valid, just politically inconvenient. What's most striking about the Cammer's legacy is what it represents in automotive culture, the road not taken. It stands as a symbol of what American manufacturers could have built if racing rules and market demands had aligned differently. Instead of pushing into overhead cam technology in the 1960s, Detroit stuck with pushrod engines for another 3 decades, refining old designs rather than embracing new architectures. The Cammer suggests an alternate timeline where American V8s evolved toward European sophistication, where technological innovation mattered more than tooling costs and regulatory politics. Imagine a world where overhead cam American engines became the norm in the 1970s, where domestic performance kept pace with European technological development. The Cammer proved that world was possible. NASCAR ensured it wouldn't happen. There's a parallel between the Cammer's story and current debates in the automotive industry. Today's manufacturers face pressure to electrify, to abandon internal combustion in favor of motors and batteries. Some see this as progress, others view it as the loss of something essential. The Cammer reminds us that progress isn't linear, that superior technology doesn't always win, and that sometimes the best engineering gets sacrificed for reasons that have nothing to do with performance. Whether electric vehicles represent inevitable evolution or enforced change depends on your perspective, but the Cammer's story suggests we should be skeptical when authorities choose technology winners based on convenience rather than merit. The sound of that engine wasn't just horsepower, it was defiance cast in aluminum and steel, a mechanical argument that faster and better should matter more than convenient and controllable. In 1965, NASCAR chose differently. What began as an experiment in overhead cam performance became a legend long after Romeo engine plants stopped building them and moved on to engines that would never challenge the rulebook. Return to that dynamometer cell at Romeo in 1964, to the moment when Ford's engineers first heard the Cammer reach peak power and understood they'd created something extraordinary. They knew it was fast. They didn't yet know it would be too fast for the only racing series that really mattered. The 427 single overhead cam Cammer remains one of the great what-ifs in American motorsports history. It proved that Detroit could build engines as sophisticated as anything coming from Europe, that American engineering could push boundaries when given the freedom and funding to innovate. It also proved that technology alone doesn't determine winners, that politics, timing, and sanctioning body relationships matter just as much as horsepower and valve control. For enthusiasts who love underdog stories and forgotten innovations, the Cammer represents something pure. Engineering for its own sake, the pursuit of speed without compromise. It didn't win championships because it never got the chance, but it won something more lasting, a place in history as the engine that was so good it had to be banned, so advanced it threatened the competitive balance of an entire sport. Today, the few Cammers that still run do so in private collections and at vintage races, their 6-foot timing chain spinning, their overhead cams precisely controlling valves and hemispherical chambers, making the same mechanical scream that stunned engineers 60 years ago. They're reminders of when Ford bet everything on being faster and discovered that in racing, being too much faster can be its own kind of failure. If you've ever seen a 427 Cammer fire up, or if you've heard stories from someone who raced one, share your experience in the comments. These engines are rare enough that every encounter matters, every memory contributes to keeping the story alive. The Cammer lost its war with NASCAR, but it won something more important. It proved that the impossible was just a matter of putting the cam in the right place. Thanks for watching, and I'll see you in the next video.